What's up people, and welcome to Quick Maths. In this video I'll be explaining the difference between linear and quadratic equations. A linear equation is an equation in the form of y equals mx plus c, involving a constant and a first order linear term, where m is the slope and c is the y-intercept. So when plotting a linear equation, the result will be a straight line. Let's look at a few examples of some linear equations. So the first one, let's say y equals 3x plus 1. So automatically we know this is a linear equation because it has a constant and it has a first order linear term and it's in the form of y equals mx plus c. So here the value of m is 3, so m equals 3. And that's our slope. And a slope can also be written as m equals rise over run. And I'll explain more on this later. And we know this is equal to 3, or 3 over 1, which is the same as 3. And here, our c is equal to 1. And this is the point where we will intercept our y-axis. So, let's look at one more example. Let's say 4 equals 2x minus y. So, this is not in the form of y equals mx plus c. However, we can rearrange this equation so it's in the form of y equals mx plus c. So we have y on the side, so we can move it over to the side. So y equals 2x, so we have 4 on the side of the equation, so we need to minus it from both sides. So we get y equals 2x minus 4. And now, this equation is in the form of y equals mx plus c, where m equals 2 and c equals negative 4. Okay, now let's look at some more examples and plot them on our axis. Okay, let's start with the example y equals 2x plus 1. So here, we know our slope, which is m, is equal to rise over the run, which equals to 2 over 1. And the coordinates of our y-intercept is 0 and 1, which is saying when x is 0, y equals 1. So with this information, we can plot the graph of y equals 2x plus 1. Okay, so starting with the y-intercept, x equals 0, y equals 1. Now, with our slope, we know we rise up 2 and then run across 1. So this rise over 1 can also be applied going in this direction. So instead of rising up 2 and going across 1, we go down 2 and across 1. Same thing, go down 2 and across 1. And here we start plotting our coordinates for our straight line. So if I join the dots here, try to get as straight as possible, we get the equation of we get the plot of y equals 2x plus 1. And you can see this is a straight line, so it's a linear equation. Let's look at another example. Let's say 3 equals x minus y. So this is not in the form of y equals to mx plus c. However, we can rewrite it as y equals x minus 3. So now we know our slope is equal to rise over run, which equals to 1 over 1. And the coordinate of our y-intercept is equal to, when x equals 0, y equals negative 3. So let's start at this point. We rise up 1, across 1, rise up, across 1, rise up 1, run, and you get the point. So I start plotting these in, and now we connect our lines, a dot, sorry. So this is the plot of the equation y equals x minus 3, and again it's a straight line, so it's a linear equation. let's look at one more example of y equals 2. So we know our linear equations are in the form of y equals mx plus c. But in this case, m is 0. So we're left with just the y-intercept, which is y equals 2. Since there's no slope, we know it's just going to be a straight line going horizontally. So this is the plot for y equals 2. Now we'll look at quadratic equations. So quadratic equations are equations where the highest power of x is x squared, written in the form of ax squared plus bx plus c equals 0. So let's look at some examples. The first one will be x squared plus 4x plus 4 equals 0. Now, we can tell this is a quadratic equation because the highest power of x is x squared. So we don't have an x cubed or x to the power 4. The highest power of x is squared. So let's identify what a, b, and c equals. So a equals the coefficient in front of the x squared, which is 1. B equals the coefficient in front of the x, which is 4. B equals 4. And c equals this constant over here. So c equals 4. Now let's look at another example. 3x squared plus 2x plus 3 equals 0. And again, we know this is a quadratic equation because the highest power of x is x squared. So let's identify a, b, and c. So a equals the coefficient in front of the x squared, which is a 3. B equals the coefficient in front of the x, which is a 2. And c equals this constant over here, which is 3. Cool. Let's do one more example. Minus x squared plus 2x plus 4 equals 0. So, again, we know this is a quadratic equation because the highest power of x is x squared. So let's go and work through what a, b, and c equals. So a, again, coefficient in front of the x squared, which is negative 1. B equals coefficient in front of the x, which is 2. C equals a constant over here, which is 4. So C equals 4. Cool, and that's a wrap of this video. So hope you've learned what the difference is between linear and quadratic equations.